you look at the systems which are likely to be inducted in the next few years, you have the Anand Shastra, which is the QR tank, you have the guided Pinaka, you have the advanced lightweight torpedo, the trawl assembly, infantry floating bridge.
3, 2, 1, now.
You have the long range land attack cruise missile. You have the long-range anti-ship missile. You have the Akash anti-system, the air-to-air missile Astra Mark II. So in the next 2-3 years, we should have several systems inducted. We have the light tank. We have the high-endurance autonomous underwater vehicle. The very short-range air defense system, the naval anti-ship missile, the Rudram 2 air-to-surface missile. So in spite of our working in silos, we have achieved quite a bit, and in the next 2-3 years, several new systems. The topic that I have chosen today is defense R&D, challenges and the road ahead. So let me start with the brief introduction. The world we live in today is in a phase of transition. We are in a state of geopolitical churn. We are moving from a unipolar world to a multipolar world. And India is going to be one of the strong poles in this emerging multipolar world. This is because of the size of our economy, the size of our population. Our rise cannot be stopped. We are also living in a world where technology is changing very rapidly. Earlier, you could take 10 years, 15 years to develop a technology. It would still remain state of the art for the next 15 years. But today, that is no longer the case. You can't afford to take that long to develop a technology because the technology itself is getting obsolete in 5 to 10 years. We are also living in a world where a lot of new disruptive technologies are emerging. AI, ML, quantum technologies, photonics, these are having a disproportionate effect on the weapon systems. In fact, in all our lives also, these technologies are rapidly affecting how we live itself. We also have the nature of warfare itself is changing quite dramatically. Earlier wars were being fought only on land, air and the sea. But now space, cyber, information, these domains are emerging. And if you ask me, before any major conflict starts, you're going to have cyber and information warfare dominate, which will hamper your logistics, your ability to fight a conventional war. The warfare is also becoming network-centric. The use of autonomous platforms is increasing. And of course, to avoid collateral damage, we need precision strikes. We also have ambition as a nation. Our Honorable Prime Minister has given us a call that we should become Atmanirbhar. He has also set as a goal that we should become a developed country by 2047, Viksit Bharat as he calls it. And he has also given us a challenge that we should become a technology leader. And especially in defense technologies. So these are the nation's goals which we have to consider going ahead. Now, if you look at the present defense ecosystem, you have three pillars. You have basic research, which is usually done in academia. You have applied R&D, design and development, and you have production. Today, if you look at our ecosystem, we work in silos. The overlaps are minimal. Of course, there is a fourth pillar, which is the user, which also has to get integrated in the three pillars. So if you look at broadly, defense R&D mostly done in DRDO. Of course, there is some support from academia and MSMEs. Design and development of systems also happens mostly in DRDO, though this is changing now. A lot of PSUs and industries have started design and development. And production, till very recently, till the defense sector was opened up, used to happen either in PSUs or ordnance factories. Now private sector is getting in, but mostly this production happens based on TOTs either from DRDO or from abroad. So this is broadly the defense R&D ecosystem today. However, we have not done badly even though we are working in silos. Today, I would say, if not full self-reliance, we have fair degree of self-reliance in all the areas that I have listed. Missile systems, armored vehicles, military bridging systems, artillery, guns and ammunition, light combat aircraft, helicopters, ships and submarines, AEW&C, radars, EW systems, sonars, torpedoes, to name a few. We don't have complete self-reliance. For example, in the light combat aircraft today, the dependence on aero engines is still exists. Similarly, we have dependence on semiconductor chips today because we don't have any chip manufacturing in the country. All our electronic systems, we are still dependent on foreign countries. Certain materials such as carbon fibers, so any composite, our dependence on foreign sources still exists. So although we have achieved fair degree of self-reliance in these fields, we still need to focus on some critical elements which keeps our dependence on foreign countries. If you look at the systems which are likely to be inducted in the next few years, you have the Anand Shastra, which is the QR fan. You have the guided Pinaka. You have the advanced lightweight torpedo, the trawl assembly, infantry floating bridge.
3, 2, 1, now.
You have the long-range land attack cruise missile. You have the long-range anti-ship missile. You have the Akash anti-system, the air-to-air missile Astra Mark II. So in the next 2-3 years, we should have several systems inducted. We have the light tank. We have the high-endurance autonomous underwater vehicle. The very short-range air defense system,
3, 2, 1.
the naval anti-ship missile, the Rudram 2 air-to-surface missile. So in spite of our working in silos, we have achieved quite a bit, and in the next 2-3 years, several new systems will also get inducted. Now, if you look at the defense capability pyramid, we have today established capability in system configuration and design, system engineering and integration, system testing, evaluation, qualification and certification, in the development of subsystems, in the development of components, device manufacturing, in machine tools, fixtures for manufacturing, as well as materials development for production at scale. So we have built capabilities in all these 7 areas, but there is lack of capacity. If you have to fight a sustained war, you also need, in addition to capability, capacity to produce at scale in a very short period. So although the defense capability pyramid now in the country is fairly good, we need to look at how we can build capacity. A serious problem that we are facing is in talent. Today, talent is at a premium. People are willing to pay very high salaries to acquire the best talent. Today, government organizations face the challenge, especially in these new areas such as AI, to attract the best talent, because the kind of salaries they get in the civilian domain is so high that in communication, in electronics, in AI, we are finding the brightest people are not coming. So this is again, and as a country, we are encouraging the global capacity or global capability centers in the country. Our brightest talents are working for foreign companies where the IP then belongs to that country. They are not working for technology development for the country. So this is again a challenge which we have to overcome. The next is, as I said, capacity. Because of our acquisition process, which wants competition and selection by L1 method, no company is willing to set up capacity. They are not sure that they will get the next order in that domain. So they say, why should I set up capacity? Only once I get an order will I set up capacity. It's not a sustainable model. If you look at, US has only Lockheed Martin and Boeing looking at, aircrafts and missiles. Very few. Russia has 1 or 2 companies. We cannot encourage competition to an extent where we don't build capacity or capability in a given company. So this is again a challenge which we need to overcome. So far, we have avoided this civil-military fusion. We have kept our defense R&D separate, civil R&D separate. Because of sanctions in the past, after our nuclear explosion in Pokhran, we had sanctions. So we had kept our civilian R&D, defense R&D, which was then subjected to sanctions, separate. Unfortunately, we continued that trend once those sanctions were removed. If you see globally, there are a lot of domains where now the civilian sector is far ahead of the military sector. If you look at communication, AI, the civilian sector is far ahead. Unless we leverage the expertise and the technologies developed in the civilian domain, our military technologies will not be up to the mark. Again, one big challenge we have is lack of risk appetite in the country. And this is not true. This is true not only in the government sector, but even in our private sector. Everyone wants risk-free investment. They want return on investment within 3 years. If you want to do cutting-edge R&D, you have to look at taking up riskier projects. Only then can you achieve technology leadership. Culturally, we are also intolerant of failure. In government, we get audited saying that you have caused loss of money to the exchequer if your R&D project fails. So what that does is you take up only incremental R&D. There the chances of failure are less. You may get delayed, but your chances of failure are less. Unless we encourage failures, you have to fail fast. You learn much more from your failures than you learn from your success. So we have to bring in this culture of I would not use the word promoting failure. You should encourage people to take chances, even if they fail, as long as genuine efforts have been put in. You should not penalize a person who takes high risks. We all admire DARPA, but if you look at DARPA's projects, the success rate is 10 to 15%, but they address moonshots. So their technologies which come out of DARPA projects really change the nature of the field in which these technologies are developed. We have to encourage that kind of culture. You need incremental R&D, of course, but you also have to encourage high risk taking in R&D. Then the ease of doing R&D, you must have heard of ease of doing business. Similarly, we have to improve the ease of doing R&D in the country. Today we treat R&D the same as we treat acquisition or procurement. You have to follow the same methods because we treat R&D is the same. You know everything what is going to happen. So you have to go by the L1 method. Unless we improve the ease of doing R&D, we will not attract the best talent to do R&D. We will not get the best results from the R&D we do. So this is again what we need to do. So for this we have to address our GFR. Unless we address this, these challenges are not going to be overcome. Then, although we want to be a technology leader, if we look at our funding for R&D, it is very poor. If you look at the R&D spend as a percentage of GDP, India lies at 0.65%. And if you look at our competitors, they are all more than 2%. South Korea, in fact, spends 4.8% of their GDP on R&D. This is overall R&D, not defense R&D. And as I said, a lot of the civilian R&D now is becoming increasingly relevant for defense R&D. Even in the 0.65%, it is mostly done by the government sector. 70% of the total R&D funding is by the government. Only 30% is by the private sector. And this too only happens in a few sectors such as pharmaceutical and now in IT space. This has to change if we have to become a technology leader.